this is Atu for Shiran, and this is the demo video of my project customer segmentation. So why should we perform it? Basically for targeted marketing and to get an idea of the future monetary value to be expected from the customers from each of these segments. Few strategies could include using the geographic data of the customers and then segmenting based on demographic data, or one after the other of these, or all of them combined. We'll focus on the purchasing behavior part. What information we require, when the customer has joined, when or how much the customer has interacted with business, and the amount spent on the transactions. Few definitions. Recency is how recently the customer has made a purchase with, which could also be found out by the difference of the end of observation date minus the last purchase date of the individual customer. Frequency is the sum of the purchases made. Monetary value will be the sum of the amount spent on each purchase. Okay, after segmenting, we will also find out the customer lifetime value, which will give an idea of the future monetary value to be expected from the customers. There are many strategies like aggregate analysis, probabilistic models, squad analysis, survival analysis models. We'll focus on the probabilistic models part here. There are few probabilistic models listed here, and we'll focus on the BGNBD and the Gamma Gamma model. Okay, few assumptions for BGNBD model. When a user is active, the number of transactions in a time t is described by Poisson distribution. Poisson distribution helps in predicting the probability of happening of future events using the previous data of how often the event occurred using the parameter lambda. For example, if a customer makes 4 purchases on an average in the interval, this red line, then the probability of making 9 purchases will be 0.03. Heterogeneity in transaction across users has gamma distribution. Gamma, just like exponential distribution, is used to predict the wait time until the very next event to occur. Gamma distribution is used to predict the wait time until the next kth event, and with the parameter alpha and beta for shape and scale. For example, if a customer who makes 5 purchases on an average, this blue line, on an average, then to make the next one transaction beta, the next one transaction, the customer to take more than 5 days the area left to it, and to take less than 5 days to make next one transaction will be the area right to it. Users may become inactive after any transaction with probability P, and the dropout point is distributed between purchases with geometric distribution. Let's see what is geometric distribution. Geometric distribution is used to show the number of Bernoulli trials needed to be conducted for the first success. Where by Bernoulli trials, I mean an experiment which will have only 2 outcomes to success in future. For example, if a customer churns with the probability of 0.7, the green line, and then the probability of churning after the 6th transaction is 0.1. Heterogeneity in dropout probability has beta distribution. Beta distribution is used to show the probabilistic distribution of probabilities using parameter alpha and beta for success and failure. For example, the alpha beta will be priors here. For example, for a user with success rate of churning 2 and failure rate of not churning alpha beta 5 here, can can have the churn distribution as this orange line. Transaction rate and dropout probability vary independently across users. For gamma-gamma model, the basic assumption is that the mean transaction value varies across users but does not vary for individual users over time. That is, most of the customers will have their monetary value around the mean. Few definitions which will be used in calculating the customer lifetime value based on our BGNVD model is that while calculating recency, we exclude the first purchase. Also, while calculating frequency, we exclude the first purchase, and moreover, the frequency is the sum of the times the customer had an interaction in the time period. The time period could be days, weeks, irrespective. So if we are taking it as days, then we exclude the number of transactions he made in the day, in one day, and only account for the date he had a purchase in. Monetary value over here is the average amount spent by the customer, including the first purchase, and age is just how long has it been since joining the customer. KPIs of this model will be the churn prediction, if the customer will churn or not, with number of future transactions to be expected from the customer, and the lifetime value, which could be multiplied with the profit margin. Now let's jump into the implementation part. Okay, so I had integrated this project in my previous project, which was used to solve supervised machine learning problems using the AutoML. So I have already added 2 customer segmentation projects. The project can be added using the add customer project, and the title, description, and the file regular expression can be provided here, and the column schema and cloud platform can be selected from here, and add project will add the project on the dashboard. So this is this CD now customers data, and the train schema has been defined here, the file regular expression and sample file name with the number of columns and the column names. Moreover, this is the important part which will define which of these columns are ID column, the recency, frequency, monetary, and the age column. The client can also pass the transaction date value instead of the recency frequency column. Next, we can add the files from the configure part. For example, I will choose the files with the specified regular expression. I had tested the project with these data sets. We can also test it using the online retail data set. The add files will actually add the files firstly to the cloud I chose, for example the GCP storage bucket, and then using the master data management I will combine, aggregate, pre-process the given data into a single file and upload it to the warehouse BigQuery. After adding the files, we can actually train the model from here, and we'll get a notification or when the training part has started, and also after the training has been completed. We can check the report after that. Okay, so the segmentation description. Okay, this is the labels which have been given to the customers. Loyal customers over here has the most priority. Okay, and there. Okay, so there are only 3 customers in the loyal part, and they are loyal because they had most of the monetary value and around the average recency value and 14th frequency value. And their LTV, okay, we can see that their LTV is very less, and they have some probability of churning. Okay, and most of the customers are in the new part, and we can expect a purchase in future from them, and the probability of churning is less. Okay, and the from at-risk customers are 121, and they have most of the probability of churning. This is because usually the new customers will have the may not come again after experimenting with the project with the product. Okay, this is the graph of the customer lifetime value to be expected from the customers, where the average is $412 or whatever the value was given in the monetary column. This shows the this is a square tree map which shows the distribution of the customer segments. We can see that the new customers take the most of the part, and the graph looks small a bit. Here we can see that 65% of the customers are new, 10% of them need attention, and there are 5 customers at risk, only 3 customers are loyal. Okay, this could also be because the data provided was very less small. Okay, the project also had been uploaded on the cloud. The project has been uploaded on the cloud as well using CI/CD pipeline on the Google Cloud platform.